Hello, everybody, and welcome to lesson 7.2, special right triangles. And this is on page 426 in your textbook. So there are two special right triangles. And remember, the word right means you have a 90-degree angle. So there's two special 90-degree angle triangles that we're going to talk about now. And those are the ones you will use in trigonometry, which comes next in our lessons here. So the first one is called, so we're in the middle of the page, it's called a 45-45-90. So right here, whoops, it talks about that. And what does that mean? It means that you have a right triangle where one angle is 90 and the other two angles are 45 degrees each. Now notice that makes it an isosceles triangle because you got two base angles that are equal. That means you have two equal or congruent sides. And that means you have a number that's the same value for the length of each side. And then that's why there is an X here and an X here. So that number is unknown. And this base side is called Y because it's different. It's a different number than this X is right up here, okay? So let's look at the theorem. First of all, let's read what it says here. Essential understanding. Certain right triangles have properties that allow you to use shortcuts to determine side lengths. So it's about side lengths without using the Pythagorean theorem. Before we used this Pythagorean theorem to find the side length of any part missing in a right triangle, but you don't have to if it's a 45-45 90-degree triangle. So here's the explanation, what it's about. The 45-45 90-degree triangle theorem says in a 45-45 90-degree triangle, both legs are congruent, which we just talked about because it's an isosceles triangle. And the length of the hypotenuse is the length of a leg times the square root of 2. So the hypotenuse is your longest side. It's always across from the right angle. These two are called legs. So this is a leg and this is a leg. And in our picture, we have our 90-degree angle here, 45-degree angles here, and they call the length of the leg S, which is a letter that stands for a number. Here in this picture, they called it X. It can be any variable. Let's make it X just because we don't want to get all mixed up. So the legs and the hypotenuse is the length of the leg times the square root of 2, always in every 45-45 90-degree triangle. Okay, so right here is the sentence I want you to remember. The hypotenuse is the leg times the square root of 2. Okay, going to the next page, 427 to the top, finding the length of the hypotenuse. What is the length of the hypotenuse of a 45-45 90-degree triangle with leg length 5 times the square root of 3? So I like you to start by drawing a right triangle for these kind of questions. If they don't have an image there, you draw it yourself. Here's your hypotenuse. This is your hypotenuse, right? What is the length? So that's what we're looking for. What is the length of the hypotenuse with leg length 5 times this? Oops, I drew that wrong because it's a 45, 45, 90. So these two are equal. So the leg is 5 times the square root of 3. This one is 5 times the square root of 3. And this is what we're looking for, the hypotenuse. Okay. So I'm going to write the sentence from the previous page. The hypotenuse equals the leg. That looks like bag. Times the square root of 2. That's what I got from the previous page, right? That I circled, okay? So the leg is 5 times the square root of 3. So that's your leg right here. And then we times that times the square root of 2. So the numbers under the radical you can multiply. So we have 5 times the square root of 3 times 2, which is 5 times the square root of 6. 3 times 2 is 6. So our hypotenuse is 5 times the square root of 6. Now, if you're wondering what do these numbers mean, if you use a calculator, you can plug them in and actually find an approximation, a decimal approximation of how long these legs and hypotenuse really is. But for math purposes, we use the radical form for an answer because it's more accurate. Okay, another one, find the value of each variable. If your answer is not an integer, express it in simplest radical form. That's what I'm talking about. The answer should have a radical and it should be simplified. So notice you only have one angle here and a 90 that leaves 45 for this one. So we're looking for the hypotenuse again. So this is a leg and this is a leg and they're equal, these two, and there's your hypotenuse, okay? So we're looking for the hypotenuse and I'll write that little sentence again. The leg times the square root of 2. So the hypotenuse is y. The leg is 60 times the square root of 2, right? And we're done. The hypotenuse is 60 times the square root of 2. All done. Okay, let's look at number 2. It's the same thing. The hypotenuse is the leg times the square root of 2. The leg times the square root of 2. We can multiply these numbers out under one radical. And leave your answer in radical form, it says. And we're done with this. So that's how you use this little shortcut to find the missing length. Remember, it all came back to this down here, page 426. This is where you want to kind of start out with. Make sure you have this part highlighted, and that's the equation. You just put in the numbers that you have to work with for this little thing. That's your starting point. Okay, I think I should give you an example on this one, finding the length of a leg. Okay, so let's take number 3 here. It says find the value of each variable. We got 2 of them here. Notice x and y. This is 90, this is 45. That leaves 45 with that one. That makes it a 45, 45, 90, and we can use the rules we have established. If your answer is not a whole number, integer, express it in simplest radical form. So you don't want to come up with a decimal. You want to leave your answer in radical form. So I'll start out with my little sentence. Hypotenuse is the leg times the square root of 2. But I have the hypotenuse. Do you notice this is the hypotenuse? I don't know the leg, call it y. This is your leg. I don't know why they call it two different letters. That's kind of silly. They both should be y. They're the same length, so they can't have different variables if they have different numbers, but they're the same number. So I'll call them both y. So there's my equations, and you want y, so divide by the square root of 2 both sides. So this cancels, and this cancels, and what is left is 15 is equal to y. And that would be 15 as well. Okay, so use the little sentence to get you started, like here, okay? And then plug in what you got in your diagram. So that's the 45, 45, 90. And then let's go to the page, so 429, let's go to the next one. That is 430 on the top. This is your second triangle. Remember I told you there are two kinds? This is the second one. Another type of special right triangle is the 30, 60, 90. 30 degree, 60 degree, 90 degree right triangle. Okay, there's two kinds. That's all you have to remember. And you want to keep these little theorems handy because they explain the relationship. This one is a little harder. This one is a little trickier. So notice you have a right triangle here. Here's your right angle. This angle is 60 degrees. That leaves you with 30 degrees for this one. So the two angles are 60 and 30, and there's your 90. So here's the relationship. I'm going to read it. In a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg. You notice you have a shorter leg, and the hypotenuse is twice the size of the shorter leg. And I don't like S, I'm going to call it X. Yeah, so the shorter leg is across from the 30 degree angle. So the shorter leg opposite the longer leg, this one, is across or opposite the 60 degree angle. Okay, so shorter leg across from 30, longer leg across from 60. Okay, and the hypotenuse is always across from the 90. So here's what it says, that the hypotenuse is twice the size of the shorter leg. Okay, that's the first one. Now, the longer leg is the shorter leg times the square root of 3. So I'm going to write that here. Oh, you got it right here. These are the sentences I want you to use when you write your equation. In a 30, 60, 90, the hypotenuse is twice the shorter leg, and the longer leg is the shorter leg times the square root of 3. That's the relationship. Notice in the 45, 45, 90, it's the square root of 2 that you're dealing with. And in the 30, 60, 90, it's the square root of 3 that you're dealing with. So that's the difference. Okay, because sometimes you're like, oh, is it the square root of 2 or the square root of 3? 45, 45, 90, square root of 2. Think of, you have 2 equal angles. And then 30, 60, 90, it's the square root of 3. Think of 3 different angles. That's kind of helps me remember that, okay? So this right here is super important. So this is where your equations will start. Okay, so on the bottom of this page, let's start with problem 4. Okay, what is the value of f in simplest radical form? So it's the hypotenuse. See, the f is the hypotenuse. Okay, so let's look at our sentence. And then d is the shorter leg, and this is your shorter leg across from 30. 5 is your longer leg across from 60. We're gonna find f. So I'm gonna, because I have the longer leg, I have a number for the longer leg. I'm gonna look for the equation that is the longer leg. So I'm gonna use this one. Longer leg is the shorter leg times the square root of 3. Oh, I don't have the shorter leg, so I have to find both. Okay, so now that I thoroughly confused you at home, let's, I'm gonna say hypotenuse. No, I'm gonna start with the other one. I'm gonna say longer leg. I had to think for a minute because you got 2 variables. You need at least one more to get the hypotenuse. Longer leg is shorter leg times the square root of 3. So the longer leg is 5 equals shorter leg is d, okay, times the square root of 3. To get d alone, divide by the square root of 3 both sides. And d, which is this one, is 5 divided by the square root of 3. Now, there's something in algebra or trigonometry that says you cannot have a radical in the bottom of your fraction. It can be in the top, but not in your bottom. So I'm going to show you how you're going to fix that. So you're going to rewrite the radical in the top and make the bottom that whole number 3. So you move your radical to the top, and on the bottom you just have that 3. That's your d5 square root of 3 over 3. It's called rationalizing the denominator. So there's d. So that's the first part. We still have to find f. So f is the hypotenuse. So I'll start with my new sentence, hypotenuse. Is 2 times the leg, the shorter leg. Okay, so the hypotenuse is f right here, equals 2 times shorter leg is this, 5 square root of 3 over 3. And when you multiply this, you only multiply these two. That will take care of the whole thing. 2 times 5 is 10. And that would be the answer. So notice the 30, 60, 90 is a little bit more complicated than the 45, 45, 90, but how can you write an equation that relates the longer leg to the hypotenuse? I say start by writing out the sentence. This is a sentence. Okay. All right, so we're moving on to the next page, and this is page 431. I'm on top. Let's do number 7, find the value of each variable. We got X and Y if your answer is not in simplest radical form. So far, we've kept them all in radical form, our answers. So this is your hypotenuse. I'll put an H. This is the longer leg. This is the long leg, short leg. This angle here is not there, so it's got to be a 60 because 30 plus 60 plus 90 is 180. So if they're only giving you 2 angles, you can find the third one easily. We've done that many times, right? So let's look at our sentence. Longer, I'm starting out, longer leg equals short leg times the square root of 3. The longer leg is y equals, I don't know the shorter leg. Don't know the short leg either, so that's x. That doesn't get me anywhere. You notice that? Because I still have 2 variables. So sometimes you backtrack. Let's use hypotenuse. So let's go and write down the second sentence. Twice the shorter leg. Okay, we don't know what, oh, I know what the hypotenuse is. It's 40, right? Twice the shorter leg. Shorter leg is x, right? So now I have 1 variable and I can find that variable. 40 divided by 2 is 20. Now I got to find y, but notice here, up here, I can plug in for x20 and I have y. X is 20, so take that 20 and plug it in here. Oops, right there, you plug in 20 and then you get your answer and you're done. Okay, so this is how these work. Let's look at number 8. We got, let's start out. Notice up here, I wrote the first sentence and it didn't work. Well, sometimes that happens. You just kind of go, okay, that won't take me anywhere. I'll try the next sentence. So that's how you work these out. So on this one, I'm looking for, this is your hypotenuse, put an H, that's your longest. This is the short leg and the long leg. Okay, short leg, long leg. Okay, so let's start with longer leg is equal to short leg times the square root of 3. So the longer leg, oh, I have a number, notice that. So I'm replacing that with a number. And then equal sign comes here, short leg, don't know, but I'm gonna have a y times the square root of 3. So I have an equation with 1 unknown quantity. I can find that 1 unknown quantity. Divide, divide, cancel, 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 cancel. 2 equals y. Y is 2. Okay, now I have to look for this, but I know that's twice this one. Is short leg times 2. So the short leg is 2 times 2 equals 4. And there you are. Okay. So an application of this theorem is right here in this number 9, architecture. An escalator lifts people to the second floor of a building. So there's your escalator. And 25 feet above the first floor. So if you ever have a problem, a word problem that doesn't have a sketch, you draw yourself one, make a right triangle. So it's all about right triangles. So this is the floor or the ground. This is your escalator. And this is the height above the ground that you end up when you're up here. Yay, you made it to the top. How far from the ground are you? 25 feet. Do you see that? And that's a 30-degree angle. That leaves you with a 60-degree angle up in here. And that's your 90. The height and the ground are perpendicular. Okay, so again, if you don't have a drawing, you have to make your own. It helps you a lot to put things in perspective. Okay, an escalator lifts people to the second floor of a building 25 feet above the first floor. The escalator rises at a 30-degree angle. To the nearest foot, how far does a person travel from the bottom to the top of the escalator? So this is the question. How far from here to here? So this is called then X because we're looking for it. So I'll call this X, unknown quantity. Okay, all I know is this height. And I know it's a 30, 60, 90 triangle. So all the properties will hold to this. Okay, so let's see. Let's see, this is, I'm gonna change colors. This is the hypotenuse. This is the long leg across from 60. And this is the short leg across from 30. Okay, so my sentence would be the hypotenuse is the short leg times 2. Yeah, hypotenuse is the short leg times 2. Oh, well, that's easy because the short leg is 25. So the hypotenuse is 25 times 2, 50. I don't know why they say round to the nearest foot, because 50 is a whole number. Usually they say it if you have, I don't know. I hope I did that right, but it just makes sense. The hypotenuse is the short leg times 2. I think they were expecting a radical. The people travel 50 feet. Is it in feet? Yep. On the escalator. So right here is 50 feet from here to here. Okay. Okay, that's an application. We have a lot of applications of right triangles in life where you don't even think about it, but they are there. So on this one on top, city planning, It's another one, 432. A rectangular park has a walkway that joins opposite corners. So if it's a rectangular park, I draw a rectangle, and I haven't even read the question. I already know that it's something with a rectangle, okay? The joins opposite corners, so it's a right triangle. So I know that it's talking about this right triangle right here. Okay, remember diagonals on a TV measures the size of the TV. It's all about making these right triangles. A triangle formed from two sides of the park, one side, two sides, and the walkway is a 30, 60, 90 triangle. So I'm going to put that in here. Okay, I'm labeling my triangle. So if it's a 30, 60, 90 degree triangle, I can use my rule that I just used over and over again. If the shortest side of the park measures 150 feet, what is the length of the walkway? Oh, this is the same thing. It's 300, it's twice. This is making me think, I need to go back to the previous page, that there's a mistake down here, but I just don't see why. That I didn't answer this correctly. An escalator lifts people to the second floor. That's your escalator. 25 feet above the first floor. That's your height. It's the shorter leg. The escalator rises at a 30-degree angle right here. To the nearest foot, how far does a person travel? Oh, you know what? No, they're asking how far are you traveling from here to here? That's your hypotenuse, and the hypotenuse is twice the length of the shorter leg. I wonder if they wanted this distance, then you would have a decimal because it involves a radical, but they didn't word it correctly. If they want this distance, this one, then they need to ask, how far does a person travel from the bottom to the top of the escalator? Then they might have to say, what is the distance? I don't know. The question, the way they ask it, it's ambiguous if they want to know this length or this length. I don't know how you would change the question if you want to make sure you know that it's this part right here. But I have a feeling they want to know this length. And that's why they said to the nearest foot, because this right here would be the shorter leg times the square root of 3. So this would be 25 times the square root of 3. And then if you find that number, you would use your calculator. I'm just doing hypothetical now. 25 square root of 3 equals, so that would be, if they wanted to know this length, it would be about 43.3 feet. Rounded to the, oh, they wanted rounded to the nearest foot. So 43 feet. Okay, sorry, I had to think about that again. Just the way they asked the question made me think they're asking for a different answer. So these are applications. Always remember to draw a right triangle, fill in what you know, everything, and then decide what's the short leg, what's the long leg, what's the hypotenuse, and use your equation sentences. So for homework, you're going to do number 11. Now my pen is revolting. number 11, number 12, 13, 14. These are just straight out. Use this one triangle right here. Use this right triangle. This is 90, this is 60, then leaves 30. For that, ignore this part, okay? So you're not looking at this, you're only looking at half of this triangle. And then you're going to 15, which is an error. I like the errors. And then I think I have one more question on the back page. This is the last question, is right up, where are we? Right up here, this one. Page 23, think about a plan. These are a little more in depth, but it's not hard. Do you notice you got a right triangle? So you're looking at this right triangle, which again is a real life application. There's so many right triangles that we don't even think about. This is a conveyor belt that moves hay bales up into a loft of a barn. And it's always the height and the ground that form that right angle. Okay, this is the ground. This is the height of the barn, and this is the how far on the conveyor belt. This is the hypotenuse, short leg, long leg. Okay, a farmer's conveyor belt carries bales of hay from the ground to the barn loft. So starting here, there they go up, right? The conveyor belt moves at 100 feet per minute. This is a rate. How many seconds does it take for a bale of hay to go from the ground to the barn loft? So first, which part of the right triangle does the conveyor belt represent? You guys answer that. Next, you know the speed. What other information do you need to find the time? You need to know the length of conveyor belt. I'll just write conveyor belt. If you know the length, how are minutes and seconds related? 60 seconds per minute. Okay, so good luck. You want to know how long does it take for one bale of hay to climb up this conveyor belt? And that's the end. Good luck to you. See you later.